Hey y'all, today is February 11th and we are doing a little mini lesson on two-step inequalities and lesson 5-6 from Savvis. So grab a piece of paper and a pencil and a calculator and let's get started. Let's look right here at number 1. So solving a two-step inequality is a lot like solving a two-step equation. You're still using those inverse operations. So the first thing I'm going to do is I'm going to draw a line through my inequality symbol. That just helps me see that I've got two sides, and whatever I do on one side, I must do on the other. Now remember, our objective is to get this x right here by itself. And I want to undo the thing that's farther away from it first. So is this 3 farther away or is this 4 farther away? If you said this 3, you're correct. Now what kind of 3 is that? Well, it's a positive 3. So how do I undo a positive 3? I subtract 3. So I'm subtracting 3 on both sides. Now, subtracting 3, does that make me flip my symbol? No, it does not. So my symbol is going to stay greater than. Now on the side with the x, the 3's cancel out and I can bring down 4x. On the other side, 27 minus 3 is 24. So now I have 4x is greater than 24. Well, 4 is connected to x through multiplication, so I undo that with division. So I'm doing that on both sides. Now, dividing by 4, does that make me change my symbol? Nope, my symbol stays the same, greater than. So on the side with the x, my 4's cancel out, x comes down and it's by itself. On the other side, 24 divided by 4 is 6. So x is greater than 6 is our answer. So now we have to graph that. So I'm just going to start, let's go with 3, 4, 5, 6, 7, 8, 9, 10, and 11. At 6, I want to put an open circle because there's no symbol, there's no line underneath my symbol. And I want to shade all the numbers that are bigger. So I'm shading towards 7, 8, 9, 10, 11, and it keeps on going, so I'm going to include my arrow. Okay, now let's move on to number 2. So 3.5 plus 4t is less than or equal to 39.5. So same thing that I did last time, I'm going to start with a line through my inequality symbol. And my goal, remember, is to get this t right here by itself. So I'm going to undo the thing that's farther away from it first. Well, that 4 is really, really close to it, so I'm going to undo this 3.5 first. What kind of 3.5 is that? It's a positive 3.5. So I undo that by subtracting 3.5 on both sides. So subtracting 3.5, does that make me flip my symbol? No, it sure does not. So it stays less than or equal to. On the side with the t, the 3.5s cancel out, and I can bring down 4t. On the other side, 39.5 minus 3.5 is going to be 36. So now I have 4t is less than or equal to 36. Now to get that t by itself, I need to divide by 4 on both sides. Now, dividing by 4, does that make me flip my symbol? No, it does not. So less than or equal to is still my symbol. On the side with the t, the 4's cancel out, t comes down and it's by itself. And on the other side, 36 divided by 4 is 9. So t is less than or equal to 9 is my answer. And now we just need to graph that. So I'm going to start with 5, 6, 7, 8, 9, 10, 11, 12, and 13 on my number line. At 9, I'm going to put a closed circle. And how do I know I need a closed circle? Well, there's a line underneath my symbol. So I draw my circle and fill it in. And I want to shade all the numbers that are smaller. So I'm shading towards 8, 7, 6, and 5. And it keeps on going. My solutions keep on going, so I include the arrow. Okay, moving on to number 3. I've got 12 minus 3y is less than 27. So let's draw a line through our inequality symbol. And remember, our objective is to get that y by itself. So I need to undo the thing that's farther away. So is this 3 farther away or is this 12 farther away? If you said this 12, you're right. So what kind of 12 is that? It's a positive 12. So how do I undo a positive 12? I subtract 12. And I do that on both sides. Now on the side with my y, my 12s cancel out and I can bring down negative 3y. Now subtracting 12 did not make me flip my symbol, so it stays less than. And 27 minus 12 is 15. Now, how is y connected to negative 3? It's connected through multiplication. So I'm going to undo that with division. So I'm dividing by negative 3 on both sides. Dividing by a negative right here. What does that mean? It means I need to flip my symbol, so it's going to become greater than. So on the side with the y, the negative 3's cancel out, and y is by itself. On the other side, 15 divided by negative 3 is going to be negative 5. So y is greater than negative 5 is my solution. So now we just need to graph that. So I'm going to start with negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and 0. So at negative 5, I need an open circle because there's no line underneath my symbol, and I want to shade all the numbers that are bigger. So I'm shading towards 0. And I'm even going to shade my arrow because I know that my solutions keep on going. Number 4. 8 minus 1/4 n is greater than or equal to 20. So I'm going to start with a line down my inequality symbol, and I'm trying to get that n by itself. So the first thing I need to undo is what's farther away from the n, which is this 8 right here. What kind of 8 is that? That's a positive 8. So I'm going to undo it by subtracting 8 on both sides. So on the side with the n, my 8's will cancel out, and I can bring down negative 1/4 n. Now subtracting 8 does not make me flip my symbol, so it stays greater than or equal to. On the other side, 20 minus 8 is 12. Now to get that n by itself, it's connected to a fraction through multiplication. So I'm going to multiply by the reciprocal. So I'm going to multiply by negative 4 over 1. Now let's talk about that. Negative 4 over 1, isn't that just negative 4? Yeah, so I'm going to just write negative 4 over here. It's the same thing. Now keep in mind, I am multiplying by negative 4. So what does that mean for my symbol? It means it flips. So it becomes less than or equal to. On the side with the n, the 1's cancel out, the 4's cancel out, so n is by itself. And on the other side, I have 12 times negative 4, which is negative 48. So n is less than or equal to negative 48. So now we just need to graph that. I'm going to start with negative 50, and I'm going to label every other dash. So that's negative 49, negative 48, negative 47, negative 46, negative 45, negative 44, negative 43, negative 42. Okay, so where do I put my circle? At negative 48. So right here, and it needs to be a closed circle because there's a line underneath my symbol, so I'm going to fill it in. And then I'm going to shade the numbers that are smaller, so I'm shading farther away from 0, so negative 50 and beyond. Okay, moving on to number 5. So number 5, we have to do A, B, and C. So let's start with A. 1/2 x plus 8 is less than or equal to 10. So I'm going to draw a line through my inequality symbol, and I'm trying to get that x by itself. So I'm going to start by subtracting 8 on both sides. On the side with the x, the 8's cancel out, and I'm left with 1/2 x. And that's less than or equal to 10 minus 8, which is 2. Now, how can I get that x by itself? Well, I can multiply by the reciprocal. What is the reciprocal of 1/2? It's 2 over 1, or just 2. So I'm multiplying by 2 on both sides. Now I'm multiplying by a positive number. Does my symbol change? No, it's going to stay the same, less than or equal to. On the side with the x, everything cancels out. X is by itself. On the other side, 2 times 2 is 4. So x is less than or equal to 4. Okay, now let's look at B. So I'm going to solve this inequality. Draw my line through my inequality symbol. The first thing I'm going to undo is that negative 24. So I'm going to add 24 on both sides. So on the side with the x, the 24's cancel out, and I can bring down negative 3x. Adding 24 does not make me flip my symbol, so it's still less than or equal to. And on the other side, I've got negative 36 plus 24, which is negative 12. Now to get that x by itself, I need to divide by negative 3 on both sides. Okay, dividing by a negative 3 means I do need to flip my symbol because I'm dividing by a negative number. So on the side with the x, the negative 3's cancel out, x comes down, it's by itself. On the other side, I have negative 12 divided by negative 3, which is positive 4. So x is greater than or equal to 4 is my answer. So now, which of the following correctly compares the solutions to the inequalities above? So I'm comparing this solution to this one. So A, the inequalities have no common solutions. Well, that's not true. They both are either less than or equal to 4 or greater than or equal to 4. So they both have 4 in common. So the inequalities have only one common solution. I like that answer. 4 is in common. They both are or equal to 4. The inequalities have the same solutions. That's not true because some are greater than, some are less than. And the inequalities have one uncommon solution. Well, that's not true either. So B is our correct answer. Okay, moving on to some word problems. So number 6, Eugene wants to ride his bike at least 40 miles today. The first hour was mostly downhill and he rode 13 miles. He has 3 more hours to ride. Write and solve an inequality to find how many miles per hour Eugene needs to ride to meet his goal. So I've already highlighted our important question, how many miles per hour? So I defined my variable x and I said it was the number of miles. So what is some important information in our word problem? Well, he wants to bike at least 40 miles. At least is a key phrase, right? So I know 40 is going to come after my inequality symbol. And when I see at least, I need to think greater than or equal to. So I know I'm going to have greater than or equal to 40. Okay? So now I just got to figure out what's going to go over here. Okay, so again, back to our word problem, what's important? Okay, he rode 13 miles already. So 13 is important. And what else is important? He has 3 more hours to ride. Okay, and notice our question, how many miles per hour? So notice they both have hours in common. So I need x to go with that 3. So I've got 13 and 3x. How do I connect those two pieces? Well, I'm going to add them together because they're all part of his total. Now this should look like an inequality that you know how to solve. So we're going to draw our line through our inequality symbol. And the first thing I need to undo is what's farther away from the x, which is that 13. Is that a positive 13 or a negative 13? It's a positive 13. So I'm going to undo it by subtracting 13 on both sides. Okay, so on the side with the x, the 13s cancel out and I'm left with 3x. There was no reason for my sign to change, so it's still greater than or equal to. And 40 minus 13 is 27. Now to get that x by itself, I'm going to divide by 3 on both sides. On the side with the x, the 3's cancel out and x is by itself. Now right here, I was dividing by 3, a positive number. So does my sign change? Nope, it stays the same, greater than or equal to. And on the other side, 27 divided by 3 is 9. So what does this mean? He needs to ride at least 9 miles per hour to reach his goal. So he needs to ride greater than or equal to 9 miles per hour to reach his goal. Okay, moving on to number 7. Amelia can spend no more than $89 to rent a car for a day trip. A rental car costs $35 per day plus 20 cents per mile. Write and solve an inequality to find the possible distance in miles, m, that Amelia can drive without exceeding her budget. So it defined our variable for us, distance in miles, m. So I said m represents the number of miles, okay? So that's what we're trying to figure out. So what else is important information? Well, she can spend no more than $89. Can she spend $92? Nope. Can she spend exactly $89? Yes. Can she spend less than $89? Also yes. So I need that to be less than or equal to 89. Okay, now what else is important? We know that the car costs $35 per day and that it also costs 20 cents per mile. Now both of those have a per in them. So it's kind of confusing which one goes with my variable. But notice m represents the number of miles. So I want 20 cents per mile to go with my m. So I'm going to have 0.20 m. And then I'm also going to have a 35 because that's also part of the cost. So what operation will connect these two pieces? If you said addition, you're correct. So now that should look like an inequality that we know how to solve. So I'm going to draw a line through my inequality symbol. And the first thing I'm going to do is subtract 35 on both sides. So my 35s cancel out and I'm left with 0.20 m. There was no reason for my sign to change, so it's still less than or equal to. And 89 minus 35, if you put that into your calculator, you're going to get 54. Now to get that m by itself, I need to divide by 0.20 on both sides. Now on the side with the m, my 0.20 cancels out and m is by itself. Now right here, I was dividing by a positive number. So does my sign flip? Nope, it stays the same, less than or equal to. And on the other side, 54 divided by 0.20, if you put that in your calculator, you're gonna get 270. 270 what? 270 miles. So what that means is, at most, she can drive 270 miles for that day trip. Okay, or she can drive up to 270 miles on her day trip. Okay, last one. Anna wants to burn at least 400 calories at the gym. She burned 120 calories on the bike and then moved to the treadmill. If she burns 8 calories per minute on the treadmill, how many more minutes does she need to exercise? So I highlighted our question that we're trying to answer. How many more minutes? So I said that X represents the number of minutes. So what is some important information? Well, she wants to burn at least 400 calories. At least is a key phrase. So I know that 400 is going to come after our inequality symbol. Well, what symbol represents at least? If you said greater than or equal to, you're correct. So we're going to have greater than or equal to 400. Okay, now what else is important? She's already burned 120 calories. Okay, so there's nothing that tells me that that needs to go with my X. So I'm going to let that be a standalone number, 120, right? Now, what else is important? Well, then she moves to the treadmill, and if she burns 8 calories per minute, there's my key word, per minute, and I know that X represents the number of minutes, so I know that 8 and X go together. So I'm going to have 120 and 8X on this side. What operation connects them? If you said addition, you're correct, because they're all part of the total calories that she's burning. So now we just solve this inequality like normal. Draw our line. The first thing I'm going to undo is that 120, and it's a positive 120. So I undo that by subtracting 120 on both sides. So on the side with the variable, my 120s cancel out, and 8X comes down, it's by itself. Subtracting 120 does not give me reason to change my sign, so it's still greater than or equal to. And on the other side, 400 minus 120 is 280. Now to get that X by itself, I need to divide by 8 on both sides. Dividing by 8 right here. That's a positive number. Do I change my symbol? Nope, I don't. So it stays greater than or equal to. On the side with the X, the 8's cancel out. X comes down, it's by itself. On the other side, 280 divided by 8. If I put that into my calculator, I get 35. Well, 35 what? 35 minutes. So that means that she needs to exercise at least 35 more minutes on the treadmill. And that is the end of our 5-6 mini lesson. Y'all do your homework this weekend and have a good weekend.